In this problem, we're going to look at a titration and look at how you can use solution stoichiometry to ultimately find the concentration of the unknown concentration of a solution. So in this particular titration, you obtain 35 milliliters of a 0.125 molar HCl solution, so you know the concentration of the acid. You place that in your Erlenmeyer flask. In your burette, the titrant is going to be lithium hydroxide. You do not know its concentration. So we need first to have a balanced chemical equation. So I write out the formulas of my two reactants, the HCl and the lithium hydroxide. They're in solution. I've got two ionic compounds in solution. Obviously, this is a neutralization reaction, but it is a subcategory of a double replacement reaction. So the hydrogen will proceed to join up with the hydroxide, and that will form water. The lithium will join up with the chlorine. The lithium is 1 plus, the chlorine is 1 minus, so lithium chloride. That's the correct formula. I look up its solubility, and I know it is soluble. I put aqueous. I look across my entire equation, and I notice that it is already balanced. The ratios are 1 to 1 to 1 to 1. Then I want to write out the net ionic equation, because it will get to the essence of what this reaction was about. And since it's a neutralization reaction, I know that involves hydrogen ions and hydroxide ions interacting, tying each other up, and forming water. Every neutralization reaction should have the same net ionic equation. Now, since this is a solution stoichiometry problem, I would like to use that idea of stoichiometry to find the concentration of lithium hydroxide, knowing that I only needed 7.4 milliliters of lithium hydroxide to reach the end point. So we're going to try to figure out the molarity. Since these are solutions, I know they're not pure substances. I'm going to have to use the definition of molarity, the number of moles of solute per liter of solution, and I'm going to first apply that to the hydrochloric acid because I know two of the three things about the hydrochloric acid. I knew its concentration, and I knew the volume that we obtained. In that 35 milliliters, I know there are 0.00438 moles of hydrochloric acid. To do the stoichiometry, I've got to go back to my balanced equation, and I look at the relationship between hydrochloric acid and lithium hydroxide, and I notice that their coefficients are 1. Both are 1. So I know there's a 1-to-1 ratio. I know at the end point I must have added the same number of moles of lithium hydroxide as there were moles of hydrochloric acid needing neutralization. So I get the same number of moles of lithium hydroxide. Now I want to use my definition of molarity and apply it to the lithium hydroxide solution. I now have the number of moles of solute. From my data, from my performance of the titration, I also know the volume. So I plug those values into my formula, and I can see that the only way that I would need so many fewer milliliters of lithium hydroxide, it had to be more concentrated, and it turns out to be 0.592 molar lithium hydroxide.